Right now we're going to talk about member functions and program organization. If you look over here to the left, we have a UML class diagram of the class person. It has 3 private variables, a string, a double, and an integer. And then it has one public member function called print. Over here to the right, we have 3 instances of that class. We have PO, P1, and P2. Each of them containing 3 variables, the variables that are mentioned here in this class: a name, a height, and a weight. It is an error to call this function print that's defined in the person class apart from an object. So if you defined one of these in main, one of these variables, then you wanted to print that whatever was in that, or call that print function, unless it is tied to the object, it would have no idea what to print. Calling it without an object tied to it would be invalid. These, however, would be valid. So we would say the name of the variable, and then we'd use our dot operator, and then we would call print. Now, one thing that is unique that I want to mention about member functions of a class is that these functions have access to these variables. So as long as that function has access, or as long as that function belongs to that person class, it will have access to the private member variables of that class. If you were to bring this function outside of the class, it would then no longer have function to these variables. And that is kind of the essence of encapsulation of object-oriented programming. You have this object, and encapsulated within it you have member variables or data, and you have member functions or operations. So you have your encapsulated together, you have operations, and you have variables. And these tied together create a nice, safe place so that your data does not get accessed by someone who shouldn't have access to them. Now, there are still things that you need to do in order to make sure that that is true, because you can give people access to those variables or give clients access, but that is the benefit of having this type of a structure. So here we have, again, we are instantiating or creating a person object, and we're naming it P1. Then we are grabbing that object, using our dot operator, and calling the function that belongs to this class. And that function is tied to that object. And like it says here, the object becomes the default target of that function. So if you were to look inside the implementation of this print function, you would see P1's member variables being printed. You would be able to see a string called name, a double called height, and an integer called weight, and it would most likely be printing them out using the cout, and it would be cout name, cout height. So that's a possible implementation. So, but that is what you would see inside the implementation. Here we have member functions and variable access. So if you look at this time class and you see that it has the name add, but only one argument passed in, how does the function know what to add it to? Aren't we supposed to be adding 2 things together? 2 instances of our time class together? Think back to our time struct when we had add in our time struct. It had 2 variables passed in. Here we only see 1 in the time class, so it is our time 2. Okay, so moving on to the next line, we have an integer I1 equals hours. Now, if you remember back to the time struct, it would have said T1 hours. As a matter of fact, let's jump forward for a second so you can take a look. I have an example of the time struct add function. So this is what our time struct version looks like. We have the return type of time, our name is add, and passed in we have a time variable. And then over here to the right we have another time variable. So when it comes time to add up all of the seconds, so, if you don't recall what's happening here, we have T1, our hours, are being multiplied by 3,600, plus our minutes are being multiplied by 60, plus our seconds. So we're deducing all of our time into one unit of seconds so that we can easily add them together. What I'm trying to get at here is that we have this T1 being passed into our function. And when we use that variable and then a dot operator, we would have access to that object's parameters. So T1.hours now has a copy of whatever that T1 object's variables were that are stored in that object. Okay, so here, if we come back to our time add, our class implementation of add, and we only pass in one variable, how does it know which hours this belongs to? How does it know which minutes, which seconds? These hours obviously belong to T2. These minutes obviously belong to T2, and the seconds as well. How does it know who the hours belong to? And the answer to that question is that it's implied. It's implicit. Let's move back over here. When we call a function that belongs to a class and it's tied to an object, this object becomes its implicit parameter, its implicit argument. This object's data is what this prints function would use and would reference the class variables only by their names because it's implied that those variables belong to that P1 object. So in this situation, these hours, this minute, since it's not tied to anything with a dot operator, we know that it is tied to the implicit argument that's being used when it's called. So here we have the struct version of add, and we are passing in two explicit arguments. So explicit means that you can see those arguments. They are known. The class version over here, we have the differences. We have our implicit argument tied on with our dot operator, and we are only passing in one explicit argument. So again, implicit means implied or suggested, not visible. So inside the function, you don't see who it is. Outside the function, it's pretty clear who it is, right? When you pass a parameter in or an argument into a parameter space here, that is an explicit argument. It explicitly is T2 here in the with hours. It explicitly is T2. The scope operator. So let's talk about program organization. The add function as it appears outside the class. Here we have a function called add. We were just looking at it. Let's look at it again over here. So let's look at this. It has a return type of time, which is that class, the class that it's coming from. It has a return type of the time class, and it has a parameter of a time object, and it's named add. Okay, let's come back over here. Okay, so this is the implementation as if it were inside the header file. So if you had defined this inside of the class, you do not need to let that class know that it belongs to it, since it's inside of it. So if something is in your house and it was given to you, Okay, obviously, if it's not yours, it's not yours. But if it was given to you, you know that because it's in your house, it belongs to you. It's yours. Functions need a way of being defined outside of the class because there are often situations that you cannot put your function inside of your class because it's too big. It's too complex. It needs to be put outside of the class, but we still want it to belong to the class. So what we do is we use what's called a scope operator. And the two colons here is the scope operator. And we're saying scope this add function, scope it back to the time class. And if you do that, as long as you have a prototype or a declaration of that function within the time class, then this will work just fine. So that's how you know that it is a time class function that belongs inside the time class, but there was no room for it. Or the programmers didn't want to define it as an inline function, which is what this is. Technically, this is called an inline function. It is defined inline inside the class. So don't get freaked out, though. The only different element of this is what's highlighted. So we still have that same time return type. We have an add name and a time to parameter. So it's really the same. All we're doing is adding this one little caveat that says, scope this function back to the time class. Can your programs include small functions? Yes, they can. Your classes let's see. Can your class have a small function inside of it? It can. We just saw that. So how small usually do we want to allow that function to be? Well, I personally do not like to have functions inside of my .h file that have more than 4 lines to them. In my class definition, I personally do not like to have functions that have more than 4 lines in my class definition. But the rule of thumb says about 7 lines. If you start to get to that amount, it's time to move your function to the .cpp file. So it is a gray area. There's no hard rule. Nobody, and wherever you are employed or however you decide to program, that's where they're going to make that final call. But it is common rule of thumb to keep large functions out of header files or outside of your class specification. So again, just going over the organization, the class scope, when it's defined in the class, we have our class foo, our public function, our public declaration saying that these members are going to be public, good for the client to use. And then it just looks like a normal function. We have our return type, our name, and our definition. Then we move over here to the function defined outside of the class, and here we have class foo, so same class instantiation here. And then we have a public visibility keyword again. And then instead of defining our function, we have our function prototype. And then outside of our class, so notice this is in the header file over here. This one is. And then in our source file, outside of our class specification, we have that same function defined using the scope operator, scoping it back to the foo class with the same return type. So, and then obviously your function definition. So this is just a way of organizing your program.